Okay, good morning, everybody. Thanks for coming down. So this went, as any of you who are speakers at conferences will know, that you submit the abstract and the talk, and then you change your mind about what it's going to be later. So this is now 3 talks in one. And I've come up with a slightly better title for the talk. Machine learning today is like software engineering in the 90s changed my mind. So hopefully there's going to be some Q&A at the end. It's going to be a bit like a kind of story time for a while to explain some of my experiences, and then a couple of conclusions from that, and then we'll look at how some of that might apply to machine learning. Although I'll warn you that I'm using AI, machine learning, and data science interchangeably today, because that's typically how they're used, and the talk's at a high enough level that I think it applies to all areas. Right, let's begin the story. So in order to tell you about the last 20 years of software development, we need to talk a little bit about what I've done. So I'm now in marketing, but I started in C, so that's started as a C programmer, ended up running a team, ended up doing something called development support at TomTom, the people that used to make those little boxes that helped you to get to places. Development support looked a bit like what would now be called DevOps, and then moved from there through. So in order to be able to tell this story for maximum effect, I'm going to have some idea of who I'm speaking to. So put your hands up if you'd identify as a software engineer. What about DevOps or operations? What about data scientist? There we go, good. Okay, so let's say because we're starting in the 90s, some of this will be mysterious to you if you were born in the 90s. So put your hand up if you started your software career before 1980. What if you started your software career between 1980 and 1990? Started your software career in the 90s? Started your software career in the 2000s? Started your software career in the 2010s? Oh, Jesus, really? Now I'm feeling really old. Okay, so all of this will be like, so I can say whatever I want, because you probably weren't even alive. Okay, I had a very different crowd last night. It was like anyone who started their career before 1980, and it's like the whole room's hand up. It's like, right, now I'm in trouble. Okay, so this is at least how I experienced software development beginning my career in the late 90s. So you used to have, we can talk about lots of different silos, but these are the ones that are relevant. So you'd have a development team. You have design before that, but you'd have a development team, and they'd had things to a testing team, and then when that was tested, you had things to an operation team, right? And everything was very siloed. They were very different jobs. So like software developers would do what software developers have always done. That hasn't changed very much. Testers, you'd have specific testers who would take whatever you'd written and go away, and in a separate sort of band, test that and come back to you. I'm going to talk about some of the problems with this, and then some of the processes, and then apply it to AI/ML/data science/etc. So many of you won't believe me, but software development in the late 90s absolutely sucked. And one of the reasons why is because version control was like a sort of nice to have. So you'd work away in like Visual Studio or whatever, and you'd create a DLL or a jar file, and then you'd like share it with your friend, maybe on a shared drive. You might also do this with like a USB stick for source code, and this was totally normal. Now there were some reasons for this, but it was bad. Why is it bad? Well, most of you have come into your careers thinking that version control is just how people do things, right? And I'm going to talk later about different ways of collaborating, but without going into too much detail, I'm sure you can imagine why this probably wouldn't work. So you collaborate badly with your fellow software engineers, and then you create something that you think might be worth testing, so you hand it over to the testers. So you say, okay, well, it worked on my, I don't know, what would it have been, like IBM ThinkPad? It was working on my ThinkPad, and I'm going to hand it to the tester who's got a totally different machine with different libraries, a different kernel and everything else, and then they go away and test it for a week, and then they come back and they give you feedback. They say it doesn't work. You say, why? They say, I'm not quite sure. Can I show it to you? And then you talk to them for a while, right? And now you've lost a week, possibly 2. And also, in the meantime, when they've been doing that for a week, you've been working on other stuff, right, with no version control. So when they come back, you're like, where's the source for that change that I made? Oh, it's in this folder called like version I gave to Dave _V1_final, right? And then it turns out that that's on a shared drive and someone's changed it and you don't have access control, so you don't know what they've changed, so debugging is entirely impossible. Now, eventually, of course, you do actually manage to make something that seems to work, and you take it from Dave, or you get a sign-off from Dave, and you hand it over to, let's say, Sarah in operations. And Sarah has absolutely no idea how anything in software development works, because that's how operations was, right? They were plugging machines into each other. Normally, you'd have a data center in your building. It was very cold. They had to spend a lot of time in there. They plug machines into each other, and the way that you interfaced with operations is you give them a jar file, or a WAR file, or a DLL, or a bunch of PHP, and then they deploy it. And you haven't done any non-functional testing, so you don't know if it's performant. And it's not performant, because it never is. But they don't know how to debug it, because they don't know what it is. For them, it's just to, like, run this. So what do? They buy more cores to try and make it go faster, right? And nobody talks, and everything sucks. So actually, no, this is how you fix it, right? Eventually, they say, well, we've actually got some governance, but just SSHing quickly and, like, see what's going on. I have a story. I guess it's been, what's that sort of plausible deny? No, what's that thing where it's not a crime if it's 20 years ago? I don't know. So I was working at TomTom. Right. So I think I'm outside of that, and if I'm not, no one here works at TomTom, right? Or ever has? We're all friends. Good. So like 2007, I'm working at TomTom. TomTom.com gets a lot of traffic because it's not just a marketing site. It's also where all the devices call into to get updates and stuff like that. Something's not working. So I'm editing PHP on the production server. And then, like, never in my life have I done :WQ in Vim and prayed as much. Like, bam! No fires, right? So obviously, this is not a sane way to work. And this is all very funny, but of course we did, like, everyone was using software in the 90s, right? So we were delivering software. So if everything was so abhorrent, how is it that we actually delivered anything? And the way we did it is incredibly slowly. Like, we had things like change control boards. Has everyone ever been through a change control board? Right. Did you enjoy that process? No. So you come up with an idea for a new feature, and you sketch out roughly how it's going to work, and then you go to the change control board, you get a meeting with them, it's 2 weeks from now, and then it's 3 weeks from now because they're busy, and then you go and explain it to them, and it's a bit like this. You're getting interviewed about your idea for a new feature, and you haven't even written a line of code yet, right? You're saying, I think I'm going to write it this way, and then they say whether or not you can go ahead and do that. And of course you implement it in a different way because it's a mess. You also have lots of things like you'd have run books. So because operations would get upset with, the fact that it's always their fault, they'd insist that when you deliver this, like, WAR file, you also have to have, like, I suppose it would have been a Word document then. You send them a Word document that explains everything you know about it. But you don't, like, what I know about it is, like, it's written in C, it's awesome. I don't know anything about performance, things like that, so you give them the wrong kind of notes. So what ends up happening is you put in a lot of checks and balances ahead of time to remove the danger. You're forced to choose between speed and safety, right? And you don't want that. So that was the 90s. Now, a quick note on how any kind of software engineering works in general, right? All of software engineering, say 90% of it is debugging, right? You write a line of code, or you deploy something, or you change something, and then you figure out what happened, right? It's an iterative, explorative. Explorative? Is that a word? We're going with that word. Explorational. I'll go with that one. So because most of software engineering, or any type of software, is like doing something and figuring out what happens, it means you need to be able to get to an atomic, shared view of reality, right? You need to know these things were the same, and that thing changed. So things have obviously improved, right? These days, I don't know, let's use a canonical example like Netflix. Apparently they deploy 400 times per millisecond, and nothing ever breaks, and they have 29s on their uptime or something like this. So how's this happened? Well, I'm glad that there's a lot of people who actually started their career later than me in here. So Joel Spolsky, the guy who I believe is behind Trello, one of the guys behind Trello, this was written in 2000. This was a Joel test. Now, even in 2005, this list was seen as an aspirational goal by many software development teams, right? So I just kind of read it and take that in. Like, number one, this is an aspirational goal in 2005 to have version control. This is 13 years ago. So things are kind of moving quite quickly. Now, of course, in a lot of the things I'm going to say today, there's always a spectrum, right? There's a long tail. You've always got people who are doing things incredibly well, but most of the market is doing things that don't get all 12 points on here in 2005. So a quick note on types of collaboration, which is something I spoke about earlier. The reason why we collaborate is because it's very difficult these days to build anything of value with one person. So we need to collaborate within teams, like me with other software engineers, and then without teams, right? So me with operations, me with testing, et cetera, et cetera. Destructive collaboration is making copies, right? If I send you a copy of my source, now there are two versions of the world. So that when I have to do that explorative thing, where I make a change and then find out what happened, I can't. Or it's harder, right? Version control is constructive collaboration. It's kind of magical in a way. Everyone takes it for granted, but it makes everything better because it means that we can all share a view of what reality is. Now, so what's got better in the last 20 years? Like, version control is ubiquitous. Does anyone here not start a project by doing git init or something similar? Actually, I should frame that the other way around because there's some guilty people in here going, fuck, shit, that's me. Let's say, in general, version control is used by, like, what? Most? Can we go with most people? And that's great. And even operations is doing this now. There's this thing called GitOps where you deploy, like, your Kubernetes configuration through, and then you monitor the difference between, like, I said I wanted that many containers, but I've actually got this many containers. What should I do? So you see that it goes through the whole software development lifecycle. Again, seems simple, but it's kind of the magic. Continuous integration, if you look at what happened with, like, the developers and then the testers and then the operations people, there's very few testers anymore. Like, you might have some specialized testers who are doing things like security as a form of testing, right? But essentially, the development team has been subsumed by the testing team has been subsumed by the development team because we just automated all the tests. So as soon as I commit, it goes into Jenkins or GitHub or GitLab or whatever, and it runs those tests. And maybe you need some domain experts from testing that are going to come in and tell you some stuff you don't know. But most of it, you just run, right? So it's kind of that team's moved in to dev. Continuous delivery is this process of taking it a little bit further, right? So it's almost like, I'm trying to do it backwards, so it's your view. It's like dev, test, operations. So tests gone into dev. Operations, like, I don't know, the year 2000 was like an interesting time to be in operations because you were either really good at your job and you ended up like working in a data center and doing cool stuff like that, or you learned how to program and you became a developer, right? If you're an operations person that knew how to reboot a Windows machine and fix a printer, you don't have a job in most places right now because that's also been subsumed into the development lifecycle. We've automated a lot of that stuff. And what this means we can do is we can get much faster feedback, which means we can do things like Netflix as opposed to things like Windows 98. So before I said, you know, when you've got shitty processes and tooling, you're forced to choose between speed and safety. When you have nice processes and tooling, and you're able to quickly establish a shared view of the world through version control, you get to have speed and safety. Because instead of thinking, let's put loads of checks in up front, so in case anything goes wrong, you say, it doesn't matter if it goes wrong, we can fix it quickly. So we'll keep iterating. So that's how software engineering was 20 years ago, and it's doing a lot better now. How do you think data science and AI is doing in the year of our Lord, 2018? No? What do you reckon? Out of 10, what would you give it? Anyone? 6? Again, depends on who you're working for, right? So some people, we speak to people, a lot of the stuff I'm going to go through now, if you go to Uber or Lyft or Airbnb, arguably some parts of Google, you'll find that they've solved all this. But again, it's this long tail. Most people are still doing this stuff quite badly. So let's have a look at it. We've been speaking to a lot of companies, and I pulled out some quotes and took the names off, just to give you an idea of the kind of things that are actually happening in the wild. So if we'd been able to save versions, right, if we had version control, it'd be easier to audit. It's like, yeah, no shit. You're slacking Jupyter notebooks to each other. That's hard to audit, right? 2 of the data scientists that worked on a particular model have left and gone to other companies. You want to be able to see what they did and how they did it, and now you can't because they've gone, right? So I don't know what they did. Maybe like, I don't know, like RM minus F in root and then left or something. but it's not there anymore. And this is incredible, right? Like, how are we running companies like this? This is a very large gaming company. They kind of have an interesting, kind of nice development process, but no monitoring. So they threw a model in there, didn't know it was talking to a billing thing. It was, right? I don't know how big a measurable is, but let's say it's like going to be significant. This one's great. So like this is a guy that runs risk management for an insurance company who's kind of technical, and he's like pulling his hair out with his data science teams because he's like, you know, all this would have been easier, guys, if you just wrote things on, like literally just put them on paper and like take a photo of them and send them to me every day, and my life will be a lot better. And he reckons if you ask them to do that, they'll all leave, which, you know, he's probably right. So this is actually one great way to do collaboration, and it always used to work, right? The fastest ever software teams in the 90s was like a customer, a programmer, and a tester working together in a small team. You can get so much done, and after that, ROI goes down massively, even if you've got good processes. But you're not going to build Google Maps with 3 people, are you? So you need to be able to have a process that doesn't require you being able to be in the same room and talking all the time, to be able to collaborate effectively. So destructive collaboration is commonplace. We've seen shared drives for training data is very normal. Someone puts a CSV file there, CSV_v3_final, right? Notebooks literally being sent as Slack attachments in like companies that you know and might be customers of. Documentation is kind of nowhere. Everyone's like, it's a notebook, it's self-explanatory, right? You're like, no, it's not, if I'm an auditor, because I don't know what that means. And what we see quite a lot is that there'll be a lot of intermediate data. So you'll take this big, I don't know, let's say you're an insurance company and you say, I want to do something on credit risk. So you ask a guy, and a guy goes at the DBA and like spits out a query, and it turns up in a 1 gigabyte CSV file, and then you put that on a shared thing, and you say, no one ever edit that, which is not an amazing process, but like, let's say we've got that. Then what happens is I'll start doing some data wrangling, right? I'll start pulling out features, I'll make intermediate files, and I'll save them on my local hard disk, and I won't share them with anyone. I don't really need to explain why that is an awful idea. Testing isn't a big thing, as far as I can tell. We're still in this sort of it works on my machine mentality, right? It's done now. Like, I'm a scientist. Go and make it run software somewhere. Deployment. So everyone's heard of DevOps, right? I suppose. So the whole DevOps thing, I mean, I could go on a rant about DevOps all day long, because it's supposed to be, like, any good movement. No, I'll just do the rant. So, like, any movement like DevOps, which is supposed to, like, fix a problem, should kill itself when it's fixed, right? But it hasn't. It's got bigger. There's the DevOps industrial complex now, and I could go on about it all day. Anyway, the whole thing about DevOps is they had this diagram where they were like, here's dev, and here's the wall of confusion, they called it, and here's ops. And that's what I was talking about earlier, right? I throw my jar file over, and we don't speak the same language, and everybody's upset. We're doing the same now, right? You create a model, it's a blob. The people that are deploying it don't understand it. They don't understand what it does, or what it's supposed to do, or how to monitor it. And they also don't understand non-functional requirements, right? Like, it might run, it's going to have to run at a certain speed, right? It's going to have to use a certain number of cycles, because it's going to end up on an actual CPU somewhere that's going to be non-infinite. So this is difficult. So then ask the same question again. How do we, and you can kind of guess the answer now, right? Like, how do we ship anything if everything's so terrible? Well, we do it slowly, much more slowly than we could be doing. And the reason why is because the same thing that we weren't doing in the 90s and early 2000s with software engineering, right? We got the wrong processes and tooling. Now, with my sort of marketing hat on, if AI is supposed to be this incredible differentiator, and if you're betting on that, then you better be better than the other person who's also betting on that, right, in the market. You can't be crap at this. Just like, you know, if it's core to your company's like success, you kind of need to be as good at it as possible. Like, speed of execution and iteration is going to be very important. So then, what are we going to do to fix this? Now, again, I'd like to reiterate, I know I'm being sort of deliberately facetious, and I know that some people are doing it very well, but like 95% of people are not, right? So the suggestions here are not like, I'm not saying, you know, we're all crap. I'm just saying, like, there's things we could do better. So as we've seen before, this idea of constructive collaboration, the idea of version control being sort of magic, actually underpins all of these things. Like development's better with version control because we can work on a shared view of the world. Continuous integration has to have version control because if you just throw like code at it and it breaks, what broke? Right? It needs to come back to a hash so you can say it was that broke, and then you can blame someone for it. Continuous delivery is the same thing. I mean, the way that most software engineering pipelines work is you do some development here in Git, you push it to GitHub, right? GitHub gets pulled here to Jenkins or GitLab or whatever to do like unit tests, system tests, etc. And then you build a deployable artifact, like a Docker image, right? And then from here on, like the code never goes past here. Here you have a deployable artifact. So you push it to, let's say this is development, testing, acceptance, and production. You push it over here and you do some non-functional stuff on it. So maybe you do some performance tests, maybe you do some security tests on it. And if that's good, then you throw it into production. Version control is kind of enabling this all the way across. Now, actually here, this is a bit trickier because really, although we're using version control to make operations better, it won't be you that's using version control to do operations better because by the time you get there, you've got your deployable artifact, right, which is like a model that you've trained or a Docker image, or probably a model in a Docker image, right? That. So it sort of begs the question, right? If this has been going on forever, then why aren't we just doing what the software engineers do? And it's because it's a different problem. Like, if I want to actually capture the state of an entire like run in Jupyter, let's say, I'm going to need, and if I don't want to be like really anal about it, I'm going to need the input data, training data, output data, if it's the input data to a next step, right? If I have a pipeline, I need the code, I need the libraries, I might need the version of the kernel if I want to get full reproducibility. Now, I'll kind of come back to this, but you can't do this in Git. How do we continuously integrate? So there are some interesting problems here, right? Because with most continuous integration tests, you get a yes or a no. It's an assert statement, right? I put loads of stuff in. Did it come out saying Mark Coleman? If it didn't, that's a failure. You can't do this with a model. You can't have exhaustive inputs and test exhaustive outputs because that's the whole point of having a model, right? You train it to do things you don't want to have to do with like an infinite number of if or case statements. So how will we do continuous integration here? Well, instead of asserting on something, we're going to have to do something like throw a lot of data at it that wasn't training data and see if it goes like more than n standard deviations away from what we were expecting. And this starts to look a lot like production monitoring in the normal world, right? So it's less binary. It's more like, does this look or feel right? Continuous delivery, this is actually the area where machine learning is doing just fine. Like, you can go outside in the sponsor hall and find people like Parallel Machines, Parallel M, and, you know, Interact from Netflix and loads of other libraries like this that are doing, like, you give it a model and somewhere to deploy it, and it will figure out which one should be in and which one should be out, and it'll tell you if something's going wrong. And I think the reason why we're doing really well at that is because it looks exactly like the same problem you've already got in software engineering. So a lot of those tools just move straight over. A lot of that thinking is directly analogous. I'm going to skip that one. So, right, if we want to fix this, and if we agree that version control is going to help us to get there, then it makes sense to start in development. This is kind of saying what I said earlier, which is like, you know, you're going to have to version control all the things. So let's say you want to get reproducibility, right? You want to be able to get back to the thing that version control gives you, which is I want to get back to a version of the world which everybody shares is a sort of shared view of reality, and I need to control these versions, or these bits that are moving in it. Like, Docker is now the way that everything gets delivered, and it's great because it allows you to say, I want this kernel with these libraries, and then I just put different software in it. Like, that'll always be the same. So that whole part of the puzzle is solved for us. Git is, of course, fantastic for anything that's text-based because it knows how to do diffing on that, and anything that's under 100 megabytes because it doesn't do large file sizes very well. And this is one of the problems, right? If you've got some training data, a lot of people start throwing it into Git, and then suddenly it gets like 200 megabytes, and what you start to notice is that Git doesn't work anymore. It's not built for that, and it never will be. Now, you can use something like Git for large files, which is a plugin. What Git for large files does is it will take the training data or whatever, and it'll store the hash of an S3 bucket so that when you do the pull or the clone, it pulls the code, and then it pulls the large files from S3. Now, this works great unless you're collaborating on a 1 terabyte file, because every time I make a 1 byte change to that, I have to upload a terabyte and then download a terabyte again. And the whole thing's about fast iteration, right? Not like painfully slow iteration. So our proposal is that you use our tool, of course, right? Because that's why I'm here. So what .mesh does, which is an open source primitive that's in the product that I won't tell you about, which is called .science, is .mesh is basically version control that works for arbitrarily large files. So it's based on ZFS. You can put up to like 10 terabytes in there. It does all the stuff you'd expect from something like Git, which is like if you change a byte and then you want to pull my change, I'm going to send you about a byte instead of the entire amount that I sent. And it enables all these developer workflows that then underpin all the other practices that we're going to need, such as CI, CD, etc. But it's very early, and like the problem with this space at the moment for me is that so many things are happening all the time, and there's so many people jumping into it from very different industries and verticals that it's hard to know sort of what's going on. So my request to you is that if any of this seems relevant, ask questions now or catch me at the end, and I'd love to learn from you. And if any of this kind of applies to what you're doing, or just tell me I'm wrong. Say like, actually, Mark, that's a really nice talk. It was kind of funny, but we've already got all of that. So you're like, you're a year too late. But that's it for now. Thank you very much.